Did you know that quantum physics is the basis of the technology we use every day, from our smartphones to our laptops? Welcome to the intriguing world of quantum physics, a realm where particles can exist in multiple places at once, and the act of observation can change the course of events. Quantum physics is the science of the very small. It investigates the behavior of particles at the atomic and subatomic levels, and it's a world that's stranger than any science fiction. But it's not just about abstract concepts and theoretical particles. Quantum physics is also the backbone of much of the technology that we use every day. When you send a text, stream a movie, or even heat up a meal in a microwave, you're relying on principles first discovered in the study of quantum physics. This is the science that gave us semiconductors, the building blocks of all modern electronics. It's the reason why your laptop is lightweight and powerful, and why your smartphone can fit in your pocket while still being capable of incredible things. It's even behind the technology of solar panels, turning sunlight into electricity. Quantum physics is also the driving force behind future technologies that could revolutionize our world. Quantum computers, for example, promise to solve problems that are currently too complex for even the most powerful supercomputers. And quantum communication could lead to unhackable networks, protecting our data in ways that were previously unimaginable. But it's not just about the practical. Quantum physics challenges our understanding of the universe and our place in it. It asks us to accept a world where particles can be in two places at once, where the future can affect the past, and where reality itself may be far stranger than we ever imagined. So next time you use your smartphone, remember, it's all thanks to the fascinating world of quantum physics. Quantum physics didn't just pop into existence. It has a rich history dating back to the early 20th century, a time when the classical physics of Isaac Newton was unable to explain certain phenomena, like the behavior of light and the stability of atoms. A new theory was needed, and thus, quantum physics was born. Our journey begins with a man named Max Planck. In the year 1900, Planck was wrestling with a problem known as the ultraviolet catastrophe. This was a prediction by classical physics that a black body, an idealized physical body that absorbs all incident electromagnetic radiation, would emit infinite energy. This clearly didn't match with observations, and Planck knew something was off. His solution? Energy, he suggested, could only be absorbed or emitted in discrete units, or quanta. This radical idea was the birth of quantum theory. Not long after, in 1905, Albert Einstein expanded on Planck's work. He proposed that light itself was made of these quanta, which he called photons. This explained the photoelectric effect, where light can cause electrons to be ejected from a material. Einstein's work not only confirmed Planck's quantum theory, but also challenged the classical wave theory of light, further solidifying quantum physics as a new scientific paradigm. In the years that followed, other brilliant minds like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger joined the quantum revolution, each contributing their own pieces to the quantum puzzle. Bohr with his model of the atom, Heisenberg with his uncertainty principle, and Schrödinger with his wave equation. These pioneers didn't have an easy time of it, though. Quantum physics was and still is full of counterintuitive ideas and paradoxes that boggle the mind. But it's these very mysteries that make quantum physics so fascinating and so crucial to our understanding of the universe. The birth of quantum physics marked a new era in our understanding of the universe. Quantum physics operates on principles that may seem completely alien to our everyday experiences. But fear not, we're about to journey into this intriguing realm and make sense of its core principles. First off, let's tackle wave-particle duality. Now, this is one of the most mind-boggling aspects of quantum physics. In our day-to-day lives, we see things as either particles or waves. A stone is a particle. It's solid, and it's definitely not waving at us. Light, on the other hand, behaves like a wave, as it can bend around corners and interfere with itself. But here's the kicker. In the quantum world, things aren't so black and white. Particles can behave like waves, and waves like particles. It's as if our stone decided to start waving at us. Next, let's dive into quantum entanglement. Imagine you have a pair of dice. You shake them, roll them, and you get a pair of numbers. Now, quantum entanglement is like having a pair of quantum dice. However, no matter how far apart you separate these dice, as soon as you roll one, you instantaneously know the outcome of the other. It's as if these dice are telepathically linked. This phenomenon has been dubbed spooky action at a distance by none other than Albert Einstein himself. Lastly, Let's explore superposition, another cornerstone principle of quantum physics. Think of a coin flip. While it's in the air spinning, you can't say for sure if it's heads or tails. It's in a state of superposition, being both heads and tails at the same time. Quantum particles are a lot like that coin. But here's the twist. The act of checking the coin or measuring the quantum particle forces it to choose a state. These principles may seem like they're straight out of a sci-fi movie, but they're very much real and at work in the world around us. They challenge our understanding of reality and push the boundaries of what we consider possible. And that's the beauty of quantum physics. It's not just about tiny particles and complex equations. It's about exploring the fundamental nature of the universe and our place within it. These strange yet fascinating principles are what make quantum physics so unique. And remember, this is just the tip of the quantum iceberg. There's so much more to learn, to discover, and to marvel at in this fascinating field. So let's keep exploring, shall we? Quantum physics isn't just theoretical, it's at the heart of many technological advancements. Let's dive right into the core of our modern world. Quantum physics, a field of study that was once thought to be purely academic, is now the driving force behind numerous technological advancements that shape our everyday lives. Consider the humble computer chip, the brain of our digital devices. At its heart are semiconductors, materials that control the flow of electricity. Semiconductors are designed to exploit the quantum nature of electrons, showing how quantum physics has been utilized in technology we use daily. Moving from the micro to the macro, let's talk about lasers, another technology that owes its existence to quantum physics. Lasers, which stands for light amplification by stimulated emission of radiation, are based on the principle that atoms can absorb and emit light in discrete quantities. This principle, a cornerstone of quantum physics, allows lasers to provide focused, high-energy beams of light that have revolutionized industries from medicine to manufacturing. But quantum physics isn't just about the technology we have now, it's also about the technology of the future. Enter quantum computing, a field that promises to revolutionize how we process information. Traditional computers use bits, which can be either 0 or 1. Quantum computers, on the other hand, use quantum bits, or qubits, which can be both 0 and 1 at the same time, thanks to a quantum property called superposition. This potential for simultaneous computation could make quantum computers exponentially more powerful than their classical counterparts. Yet, quantum computing is not without its challenges. Quantum properties are fragile and easily disturbed. This makes building a stable, practical quantum computer a significant technological hurdle. But the potential rewards are immense. From drug discovery to climate modeling, quantum computing could offer solutions to some of the world's most complex problems. So, as we can see, the influence of quantum physics is all around us, shaping the technology we use today and driving the development of the technology of tomorrow. It's in the chip in your computer, the laser in your DVD player, and the potential of quantum computing. Quantum physics is a key player in the technology we use today and will use in the future. The future of quantum physics is as mysterious as the subject itself. One of the most exciting prospects on the horizon is quantum computing. Quantum computers, unlike their classical counterparts, use the principles of quantum physics to process information. Imagine a computer so powerful, it could perform calculations at speeds unimaginable today. It could solve problems that are currently beyond our reach, from decrypting complex codes to modeling the behavior of molecules for drug development. However, the technology is still in its infancy, and there are numerous hurdles to overcome. But the potential is there, waiting to be unlocked. And then, there's quantum teleportation. It sounds like science fiction, doesn't it? But it's not. Quantum teleportation doesn't involve physical objects disappearing from one place and reappearing in another. Instead, it involves the transfer of quantum information from one particle to another over any distance. While it's currently limited to the realm of tiny particles, the implications are profound. It could lead to ultra-secure communication systems, where eavesdropping is physically impossible. But these are just two examples. Quantum physics is a vast, largely unexplored frontier. There are countless other potential breakthroughs waiting to be discovered, and the beauty of it is we don't know what they are yet. That's what makes the future of quantum physics so exciting. The possibilities are as vast as the universe itself. Quantum physics could revolutionize medicine, computing, communication, and so much more. It could change our understanding of the universe and our place in it. It's a journey of discovery, and we're just at the beginning. The future of quantum physics holds endless possibilities, promising to revolutionize our world. Quantum physics doesn't just intersect with science, but with philosophy as well. And so, we delve into the realm where the microscopic meets the metaphysical, where quantum physics and philosophy intertwine. Quantum physics, with its inherent uncertainty and wave-particle duality, has challenged our conventional understanding of reality. It's like stepping into a world where the laws of classical physics no longer hold sway and where particles can exist in multiple states at once, only to collapse into a single state upon observation. This phenomenon, known as the superposition principle, raises a fundamental philosophical question. Does reality exist independent of our observation? This question takes us back to the age-old philosophical debate between realism and idealism. Realism posits that an external world exists independent of our minds, while idealism argues that our consciousness shapes our reality. Quantum physics, with its observer-dependent reality, seems to lean more towards idealism, but the debate is far from settled. Then there is the concept of entanglement, where particles that have interacted once continue to affect each other's states no matter the distance that separates them. This spooky action at a distance, as Einstein called it, challenges our understanding of space and time, leading us to question whether our universe is truly local or non-local. The philosophical implications of quantum physics extend to the concept of consciousness as well. Some theorists argue that consciousness isn't just a byproduct of the brain but is fundamental to the universe, much like space and time. This perspective, known as panpsychism, posits that everything from particles to people possesses some form of consciousness. And let's not forget the many worlds interpretation, which suggests that each quantum event spawns an infinite number of parallel universes. This idea not only fuels our fascination with the multiverse, but also sparks philosophical debates about identity and free will. As we delve deeper into the quantum world, we find ourselves grappling with more and more philosophical questions. These questions challenge our understanding of reality and consciousness, pushing the boundaries of what we know and what we can comprehend. As we conclude this scene, it becomes clear that quantum physics doesn't just redefine the rules of the physical world, it also reshapes our philosophical landscape. Quantum physics doesn't merely describe the nature of the universe, it challenges our understanding of what it means to be. Quantum physics challenges our understanding of reality, leaving us with profound philosophical questions. Quantum physics has made its way into our books, movies, and TV shows. This once abstract and esoteric field of science has now become a wellspring of inspiration for creators worldwide. From the mind-bending narratives of science fiction novels to the awe-inspiring visuals of blockbuster films, quantum physics has found a home in the realm of popular culture. Let's take a look at how this has happened. In literature, quantum physics provides a playground for authors to bend the rules of reality. Books like The Quantum Thief and Anathema weave complex narratives around the principles of quantum physics, introducing readers to its intriguing concepts in a digestible and engaging manner. In the movie industry, quantum physics has become a tool to craft narratives that transcend the boundaries of our conventional understanding of the universe. Films like Interstellar and Ant-Man incorporate quantum mechanics to create plot lines that are as fascinating as they are fantastical. Television has also seen its fair share of quantum physics. Shows like The Big Bang Theory and Stranger Things have characters discussing quantum phenomena in everyday conversations, making the subject more approachable and less intimidating for the average viewer. Even music hasn't been immune to the influence of quantum physics. Bands like Muse and Radiohead have referenced quantum principles in their lyrics, adding another layer of depth to their music. From novels to films, TV shows to music, quantum physics has permeated our culture, transforming from a niche scientific topic into a source of endless fascination and inspiration. It has allowed us to explore concepts beyond our everyday experiences and has sparked our imagination in ways we never thought possible. Quantum physics, once a niche scientific topic, has become a staple in our cultural narrative. There's so much more to learn about quantum physics. Quantum physics, with its intricate theories and mind-bending paradoxes, is a treasure trove of knowledge waiting to be explored. The journey into the quantum realm may be complex, but it is also incredibly rewarding. The world of the infinitesimally small holds secrets that can redefine our understanding of the universe. If you're intrigued by the mysteries of quantum physics and wish to delve deeper, there are numerous resources available to guide you. Many brilliant minds have penned down their understanding of quantum physics in the form of books. Some of the most notable ones include Quantum Mechanics, The Theoretical Minimum by Leonard Susskind and Art Friedman, and The Quantum Universe by Brian Cox and Jeff Forshaw. These books provide comprehensive insights into the world of quantum physics, making it accessible to the curious reader. The digital age has also brought learning to our fingertips. There are several online courses that offer in-depth knowledge about quantum physics. Websites like Coursera, Khan Academy, and EDX offer courses from renowned universities across the globe. These courses cater to different levels of understanding, from beginners to advanced learners. If you're more visually inclined, documentaries can be a great way to immerse yourself in the subject. Documentaries like The Quantum Revolution and Quantum Physics: A Beginner's Guide present complex ideas in an engaging and understandable manner. No matter the medium you choose, the key to understanding quantum physics is to approach it with an open mind. It's a field that defies common sense and challenges our understanding of reality, but that's what makes it so fascinating. Embark on your quantum journey and discover the wonders of the universe. Don't forget to subscribe to Epic Elite 10s for more fascinating deep dives into the world of science.